Alright, hello. Today we're going to be solving Leet code 226 invert binary tree. Given a root of a binary tree, invert the tree and return its root. So basically what we're doing is swapping the left and right child of every node. So when we get to 4, we swap the 2 with the 7. When we get to the 2, we swap the 1 and 3. And when we get to 7, we swap the 6 and the 9. Hopefully that makes sense. And I'm going to show you two solutions, an iterative and a recursive solution. First, we're going to head into the iterative solution using a stack. So here I've copied the tree that we're going to be working with here, and we're going to create a stack. And just for the example, we're gonna call it, let's just say like stack here, and it's just gonna be like, an array. That could have been more glorious, but it's what we got for now. All right, so first we're gonna initialize our stack with the root node. So let's say it has 4 in the beginning. Next, what we're going to go in and we're going to swap 4's left and right children. So let's say we're going to swap them. So the new tree would look something like this. Say I copy this down, I move it down here. And since we swap 4's left and right children, we have 4 here. And since the 7 was on the right side, now it's going to be on the left. And then 2 is going to be here. But we're not just swapping the values, we're swapping the whole entire node. So it's going to bring all its children with it. So the 6 and 9 over here will actually come with the 7. So there'll be a 9 here, 6, 9 there, and then there's going to be a 1 and a 3 here. Next, after we swap its node, we're going to see if this node has a right and left child. And if it does, we're going to push it onto our stack. So does it have a right child? Yes, a 2. So we're going to push that onto our stack. Does it have a left child? Yes, a 7. We're going to push that onto our stack. And since we already popped off the 4 because we worked with it, that's gone. And now the top thing on our stack is the 7. So we're going to go through and do the same thing. We're going to say swap 7's left and right children. So there'd be a 4 here, a 2 here. Oh, it'd be the 7 here, the 2 here, a 1 here, and a 3 here. And we'd swap its left and right children. So a 9 and a 6. Perfect. So this is the original tree, this is the first iteration, and this is the second iteration. So now when we get into a third iteration, and we already popped the 7 because we worked with it, so 7 is done, and we're going to say, does 7 have left and right children? It does. So we're going to put the right child on first. So there's going to be a 6 onto the stack because 6 exists, and there's a 9. We're going to put a 9 on there. Our next iteration, I'm not going to draw the whole tree, but just follow along with me. And hopefully this is very clear. We're going to have a 9 and we're going to pop it off the stack. We're going to swap its left and right children. But as you know, this is the last node. So its left and right children are actually null. Swapping null and null doesn't do anything. So it looks the same. And we're going to say, and we only push things on our stack that are not null. It has to have a child. This does not count as a child. So we're going to push nothing onto our stack. So it essentially did nothing. Next, we go on to 6. And same story. These are both null. It swaps the null and null. Doesn't actually change anything. And we're not pushing anything on our stack because it actually doesn't have any children. So 6 is done. Next, we're going to go on to number 2 because that was now the last thing on our stack. And we're going to have a 4, 7, 9, 6. And then now where 2 is here, we're going to swap its left and right child. So there's going to be a 3 here and a 1 here. And since we've already used 2, 2 is off our stack is empty, but we're not done with this iteration. We're going to say, does 2 have a left child? It does. So we're going to push down to our stack. A 3 here. And does it have a right child? Yes, it does. A 1. So now we have a 1 onto our stack. Next iteration, we pop off the 1. We swap its left and right children. And we know that these are null, and we're not going to push anything extra onto our stack, so this actually does nothing, so 1 is done. Next we go to the 3, same story as before, null and null, and don't push anything on our stack because those are null, and we would return the root, which would be the final tree, so this would be our answer. Hopefully that makes sense, and I'm going to show you this is exactly what the answer is. So it's 4, 7, 2, 9, 6, 3, 1. 4, 7, 2, 9, 6, 3, 1, and that would be our answer. All right, and I'm gonna show you guys how to code this up really quickly. Let's get this out of the way, and let's see here. First, what we'd like to do is create our stack. So I'm gonna say let's stack equal, and we're just gonna put the root in because that's always gonna be the first node. And we need to check if they give us an empty node, just basically a tree with nothing in it, we want to return just that tree. So if not node, not root, return root. And if you're wondering why I'm doing that, in one of the examples here, if the root is absolutely nothing, you want to just output absolutely nothing, just an empty parentheses. So we just want to input that. That's just an edge case. Now we can get into like the real meat and potatoes of the solution. So we're gonna have let's stack equal root because we want to get the root first. Next, we want to say while stack.length is true. So while the stack.length is not 0, we want to do a couple things. First, we're going to let node equal stack.pop. So that'll get us our node. So pop off our root. So here we're working with the root, but we're calling it node, storing in a variable called node. Next, we want to swap its left and right children. So we're going to say, we're going to do an in-place swap here. So we're going to say node.left, comma, node.right equals, and we're going to do the exact opposite. So node.right, comma, node.left. Something like this. And that will swap the two children nodes, or two child nodes. Next, we want to push things onto our stack. So we're going to say if node.left, and this is just saying if it's truthy. So if it's a null value, we don't want to push into our stack. Just like in our example, if we get to the null, we don't want a null on our stack. That'll throw an error. So if the left node is truthy, we want to say stack.push node.left. And we're going to do the exact same thing for the right side. Right, and if the right is truthy, we're going to push the right. Perfect. And here, that would actually be just about it, and we'd return the root. Because that after all we change, we want to return the head of the tree, which is the root, and let's see if we get the right answer. Oh, cannot initialize before. Okay. There's a slight issue here. I forgot to put the semicolon there, and let's submit. And there we go. We passed the Leet code with 100%. It beats 100% runtime. It's actually pretty efficient using a stack, and there you go. All right, so now I'm going to show you guys how to solve this question recursively. So what we're going to do is first have our base case, and we're going to say if we reach a null node, we just want to return the root. And we're not going to use the root, so it's okay. It's just going to end that call. So what we're going to do here is we're going to start off with our first node, so like a 4, and we're going to swap its left and right children. So 7 here, 2 here. Perfect. Then, instead of having a stack or something like that, we're just going to say, we're going to call the function itself. We're going to say invert tree on the left side and then invert tree on the right side. And it's going to do that same operation on each subtree. And then we just return the root. Hopefully that makes sense. I'm going to show you guys how to code that up really quickly. So first we're going to have our base case. So if the node is null, we just want to return root. It's not a node, it's called root. Next, what we want to do is swap the children. So we're going to say store a temp variable to swap them. So we're going to say let temp equal root dot left equals root right, and root right is going to equal the temp. Okay, so that's just how we're going to swap our nodes. And next, instead of calling that, since we're doing the same function over and over again, we're just going to say invert tree, and we're just going to say root dot left, and we're going to do the same thing for the right, and we're going to call the same function and return the root, something like this. And let's see, did we get the right answer? And there we go, we passed. So that's how you solve invert binary tree, and recursive and an iterative solution. I hope you guys enjoy the video. Drop a like, do all that good stuff.